Alright, this is my project on nuclear reactors and medical applications. Basics of nuclear chemistry. Nuclear chemistry is an exciting field that explores the changes and reactions happening inside atomic nuclei, which sets it apart from traditional chemistry, where the focus is on how electrons behave. Here are a few key concepts that highlight the wonders of this area of science. Radioactive decays. Imagine an unstable atomic nucleus trying to find balance. To do this, it releases energy in the form of radiation. This process, called radioactive decay, can happen in various ways, creating different types of radiation, such as alpha particles, beta particles, and gamma rays. It's like the nucleus is shedding excess energy to become more stable. Fission. Think of this as an explosive split when a heavy nucleus like uranium 235 or plutonium 239 absorbs a neutron. It can break apart into lighter nuclei. This process releases a tremendous amount of energy, which is used in nuclear power plants and weapons. It shows just how much energy can be released from even the tiniest particles. Fusions. Fusion is the opposite. It's about coming together, not breaking apart. In this process, two light atomic nuclei, like hydrogen isotopes, combine to form a heavier nucleus. This this is the same reaction that powers stars, including our sun. Fusion also releases energy, and scientists are actively working to find a way to use this clean and powerful energy to source the Earth. Energy, basics of nuclear energy and medical applications. Nuclear chemistry plays a vital role in medicine by enabling the development of diagnostic tools and treatment options. Diagnostic imaging techniques like PET and SPECT use radioactive tracers that emit gamma rays, allowing healthcare providers to visualize and diagnose conditions within the body, such as cancers or numerous diseases. Radiation therapy involves using targeted radiation to destroy cancer cells. This ensures the maximum dose of radiation is delivered to the tumor while minimizing exposure to the surrounding healthy tissues. Scientists involved. One famous scientist would be Mary Curie. She was born in 1867 and died in 1934. She was known for her pioneering research in radioactivity. Mary Curie was the first woman to win a Nobel Peace Prize and remains the only person to have won a Nobel Peace Prize in two different scientific fields, physics and chemistry. Her work laid the foundation for the use of radioactive isotopes in medicine. Specific medical uses. PET scans use radioactive isotopes like fluorine 18, which is combined with glucose to create a radio tracer. This is injected into the patient and allows for imaging and metabolic processes. It is particularly effective in detecting cancer and monitoring treatment progress. Single photon emission computed tomography SPECT scans. SPECT imaging employs radioisotopes to visualize blood and detect abnormalities in organs, particularly in the heart or the brain. It helps diagnosing conditions such as coronary artery disease. Radionuclide thyroid scanning uses iodine 123 and iodine 131 is using thyroid scans to assess thyroid function and detect thyroid disorders, including hyperthyroidism and thyroid cancer. Bone scans, technetium 99M and bisphonate is commonly used in bone scans to identify bone metastases, fractures, and infections by highlighting areas increased bone metabolism. Materials used materials such as radioactive isotopes like technetium 99M, iodine 131, and fluorine 18. They're all used for advanced imaging devices, which devices such as PET scanners and SPECT cameras. The benefit of nuclear chemistry in medicine. Early detection for things like cancer, diseases, sickness. It's effective and it leads for more research and development. Its role, nuclear energy plays a significant role in our world by providing a powerful source of electricity through the process of nuclear fission. And it also gives us a more in depth of life, human life. It helps us on the medical side so people can get the right treatment they need. Detrimentals, a risk of radiation, environmental concerns, and cost barriers. So overall, it's talking about how too much of exposure, because too much radiation is bad for a person. Environmental concerns on how it can have an effect on surrounding areas and things of such. And my sources are listed in the slide. That is it.